Okay, sweet.
So, okay, last one of the night. We are only a little behind schedule, which I'm going to count that as a win, honestly. It was the pizza, weirdly enough. So we have Mark, my fellow co-organizer of the Azure Meetup in Columbus. He has, like I said, pretty much everyone here tonight has been a teacher for me over time. And he is the guy that if you are new to the tech scene and you have questions about Azure, he'll always be at Code and Coffee. He's always around, able to answer questions, no matter how stupid my questions are. And I've asked a lot of stupid Azure questions. Yeah, it's ask any of the people that have asked questions. They're not always so good. So you're in for a treat, and of course he has the YouTube channel, the Azure Terraformer. So if you want a raw quantity of teacher, you can probably find more hours of him talking than anybody else. And I mean, that's quantity's a quality all its own. So.
I'm going for quantity, definitely not quality. I don't use a teleprompter. Most of my YouTube content is literally me just on my computer in front of a camera, just doing whatever the hell I feel like on using Terraform. So that's how I roll. Anyways, today I thought I would take a little bit of a different turn, not talking about Terraform today. We're talking more about what I do at my day job at Microsoft. Just platform resiliency, understanding like there's some major changes that have been happening to the platform over the last few years. This is not like a new thing, but like it takes a long time to kind of pivot some of these new features, especially when we talk about the underlying foundation of the platform. But yeah, as Drake mentioned, this is me. I work for Microsoft. I'm actually in an engineering role, so I always tell people I'm not here to sell you anything. Praise be to COVID, I didn't have to move to Redmond to get an engineering job at Microsoft. That's a whole new Microsoft, as a previous speaker mentioned. And I work in the Azure core team. So that's compute, networking, and storage, the foundation of the platform. Our biggest customers are other Azure services like Cosmos DB. So that's how we roll. I've in a previous life, I did a lot of consulting. So I worked on lots of other clouds, AWS, Google Cloud. This year, I just made HashiCorp Ambassador, so that's kind of fun. Mainly because, okay, thanks. Mainly because, I make funny YouTube videos and sometimes educational. So that's me. Here we go. So the agenda for today, we're going to take, just because, I don't know where everybody is, right? So we're going to take a little bit of a look at the anatomy of Azure's global infrastructure, just to set the basis so we know what we're talking about here. We're going to look at some common resiliency strategies in order to build resilient systems on Azure. We're going to look at how an end user such as yourselves would leverage the resiliency built into the platform. And then we're going to even layer on top of that, like using a Kubernetes workload, how you would build Kubernetes-based systems to take advantage of the resiliency as well. So that's kind of what we're doing today. So we talked about, I think a question came up earlier, can small clouds leverage unique features to kind of leapfrog the big boys? Yeah, I think that's definitely possible, and there's definitely potential for disruption. But I think a point was made. It's a very capital-intensive business, building a hyperscale cloud. As you can see here, these are Azure regions. Each one of these little blue dots, we are going to just do the two-finger pinch in the next slide and look at what exactly each one of those blue dots really is. Spoiler alert: it's a lot of servers. Okay. But yeah, we have a lot of blue dots. There's some little dotty dot blue dots that are pending. So, this is not an announcement, but we are rolling out lots of new regions. We are rolling out AI dedicated regions, right? I think we made some announcements recently about all this stuff in order to not burn those trees down, or maybe we're burning those trees, I don't know. But AI takes a lot of computing power. And so we really are ramping up the region, factory game. So you can see kind of the speckled little green dots. That's where we got going on. We cover the globe. I won't drain that slide, but if you want to know what region you want to go deploy to, you can go check that map. So what is a region? What is an AZ? I'm just picking on you, US West here, but in reality, a region, when you go provision something in Azure, you're actually touching multiple data centers, right? And so these little boxes right here, you're probably talking about at least 3, massive billion-dollar data centers, right? When you provision something to a region. So bear that in mind. Like, why? I think this gentleman, I'm picking on you, okay? He's like, why would I use the cloud? I got a server in my garage. I know. Dude,
Sometimes you have to pay the price for it.
sometimes I pay the price almost every day on LinkedIn, okay? All the hate I've been getting. Anyways, I make too many jokes on LinkedIn. I got to stop. No, like in my consulting days, like I'd have these startup companies, and like this, like the executives of the startup was like, yeah, so my IT guy's like, he's got a server in his garage, like, but like we're trying to do demos and like it falls over all the time. It's like, well, that's what happens when you rock on a server in somebody's garage or basement or their parents' basement, So what you pay for in each of the SKUs on the cloud, it has built into that the resiliency of these massive data centers. You've got redundant water, redundant electricity, redundant fiber to the global backplane, right? So that's part of the costs that you're buying in there, right? So I have a home lab. Like I recommend everybody have a home lab, whether it's a couple of Raspberry Pis stitched together or a rack, whatever you want to rock, man. Like, have fun, play around with your home lab. But like, if I'm going to actually go deploy something, that's going to be a production system, I would rather, have somebody like Azure or one of the other hyperscalers take care of that hard effort of building this massive infrastructure. So when we delve into what those big boxes are, right? We got those data centers. They're each individual data centers that we can deploy to. And so the AZ. So when we look at resiliency, right? We can deploy our application across 2 regions, and this is called multi-region resiliency. And so regions are typically, don't quote me on this, but like about 500 miles apart, right? They're pretty far away. So if a meteor like slams into Earth and knocks out one of these regions, right? So the other regions are probably going to be okay, right? That's kind of the idea. So if you host your application across regions, right? You get the resiliency of those 2 regions, and you're taking advantage of both of those rock solid infrastructures. Now, there are some good use cases to do that. Disaster recovery, right? Like if a meteor strikes, US West, like I got something in US East, maybe I don't have the whole thing up and running. Like I have to flip a switch and then we're ready to rock. If you have dispersed user populations, right? If you have business or enterprise, you might have certain offices around the globe, right, where you have a high concentration of your workforce, and those folks need to, VPN in, they need to access critical systems, and they need to do their jobs. And when you start moving beyond businesses or enterprise, you might be talking, maybe you're doing the next Amazon.com or the next, LinkedIn or whatever, like the next social network. That's when we start talking about hyperscale workloads where you just have a consumer audience that's huge, they're everywhere, you don't know where they are, right? And multi-region resiliency makes sense in those scenarios. It can be expensive, right? Especially if you're doing active, right? Like load balancing across, a plethora of regions. Multi-AZ resiliency is a little bit different. With AZ resiliency, you're deploying your application into a single region, and your application is now hosted in all the data centers within that region, each data center essentially becoming an AZ. And what use cases do we have for that? Low latency workloads. If you have multi-region resiliency, 500 miles, physics starts to take into effect, right? Like it literally takes a while to push those electrons across that distance. So low latency workloads, like things like Cassandra, Kafka, things like that, kind of needs to be closer together. Regional populations, if you do have a high density of people, in one location, you don't necessarily need to be all over the place, but you do want the high availability that comes with the availability zones. And then lastly, this probably applies more to our friends over across the pond, right? Data residency requirements, things like that, GDPR, whatever. But like, you literally don't want your data to leave the region at all. Like, I'm just in Germany sovereign. Like, just stay there. Like that, we're not going anywhere else. So these are two resiliency modes that you can opt for your workloads. They can be paired together, right? You can have multi-region and load balance across regions. Within the region, you can have multi-AZ. So, pick your poison. It depends on how deep you want to go, how much resiliency, how much high availability you need within your workload. So how do we make this possible? Well, it kind of starts with virtual machines. And I'm not going to go into PaaS, okay? Because a lot of the PaaS services kind of do this for you. So, I want to lay the foundation, and this will give you some insight into how we do it at Microsoft, right? Because ultimately our PaaS services are running on VMs, right? And so at the most primitive level, right? So with loose virtual machines, you can spin up a bunch of them, but Azure, if you don't tell Azure like that these virtual machines work together, then it can't really assume that, right? So we, in the traditional resiliency model for Azure, we had this mechanism called an availability set, which basically created this logical container around a set of virtual machines that you said, hey, these guys are friends. They're all trying to work together to accomplish the same task. It would be really bad if one of them went down, and the other ones kind of need to know about it. Like we can't have more than one of these guys go down at a specific time. So you roll them into an availability set. These are loose VMs. So that's Fred, that's John, that's Bill. We know them. They're not just randos that kind of get spun up. We'll get to that later. So this kind of logical container informs Azure on how to place these into the Azure data centers. Virtual machine scale set, again, is, okay, we don't have pets anymore. We don't have Fred, Bob, and Bill, or whatever they're called. We have kind of an anonymous dynamic set of virtual machines that we can elastically scale. And that's what a virtual machine scale set is. Virtual machine scale set does give us the same capabilities that an availability set does. It informs Azure, hey, these guys are all on the same team. Like, it would be really bad if we lost more than 2 of these, or a large number of these at a given time. So both of these devices allow us to, trying to make sure I hit the right button, allow us to tell Azure, hey, protect these guys, make sure you keep some of these guys healthy. And so when we look at how this plays out into a data center or a region, so we got West US, we have data center 1, data center 2, data center 3. There's no rocket science here. Data centers have racks of servers. They got network switches, top of rack, and we're going to place your workload within them. In those data centers, we have crafted fault domains, and those fault domains basically create boundaries that are tied to the critical pieces of hardware that if they fail, then that group of nodes are going to fail together. And so that's what the availability set and that VM scale set, helps inform Azure to say, hey, I can't have my whole team fail together. Like, they can't all be on the same plane. So spread them out. And so when you have loose VMs, Azure doesn't know how to spread them out. So we can't guarantee that they won't be on the same plane, right? So if that bird goes down, you're in trouble. The availability set and the VM scale set allows us to okay, like you told us, they're working together, so I'm going to spread them, so that nobody, they're kind of distributed across these fault domains, so that if a fault domain does go down, which it can happen, right? And it does happen, and you should plan for it to happen, plan for failure, right? Then the impact will be minimized as much as possible, right? Now, the last thing I wanted to point out is another construct called the proximity placement groups, which is a slight variation, and it was kind of hard to do this on my graphic here, but they can be used in conjunction with availability sets and VM scale sets, but essentially it's like when you want to have those virtual machines close together for like extremely low latency type workloads, where you want the disk and you want the NIC and all that stuff to be as close together within the data center as possible. It can still span the fault domains, right? So you can still have that resiliency when used in conjunction with availability sets. It's kind of up to you if you want to trade off the resiliency for the performance that you might get. So I just wanted to make that out there. Now, this is all fault domain-based resiliency. Now, Azure's introducing availability zone-based resiliency through rolling out availability zones to all of our regions. And so what does that look like? Well, here we are. Oh, I don't even have the display here. So availability zones takes it up another level, right? So it's no longer at the rack level or the piece of hardware within the data center. We treat the data center itself as a fault boundary within the workload, right? So previously, if you provision an availability set, all of your workloads would go within one of those data centers. When you provision across availability zones, then your workloads are going to be spread across those data centers. And so in this case, like with loose VMs, we give you the control, just like other cloud platforms, Brad, I'm looking at you, to explicitly set, okay, I've got 3 VMs, Bob, Sally, and Fred, and I want Bob in AZ1, I want Sally in AZ2, and I want Fred in AZ3, right? You can explicitly set that on the VM. So loose VMs, you have that ability to do that right away. With a VM scale set, it's a little bit different. We established, we don't know all the names, they're not pets. It's like a dynamically scalable set of compute. We give you the option to say, okay, this is kind of like an auto-scaling group, like what zones do I want this VM scale set to provision into, right? So you can inform Azure, like what zones are going to be available to this VM scale set. So how does that play out? Well, by default, when you tell the VM scale set, hey, you can provision to 2 or more zones, here are the zones I want you to provision to, it's going to do a best effort allocation, across the available capacity. That at least guarantees you to be provisioned, if you've got 3 VMs, they're going to be allocated in 2 or more availability zones, right? However, what happens if AZ2 goes down? I've got 3 VMs up and running, 2/3 of my workload is sitting in AZ2. So if AZ2 goes down, my capacity for my application gets cut at the knees to 33%, right? 1/3 of my traffic could be, can be handled, right? This could be potentially bad. So how do we solve that? We need to solve that by setting a flag to tell the VM scale set, by the way, not only do I want to make these zones available to you to provision in, it's actually really important to me personally that you spread my nodes evenly across these availability zones. There's a difference, and this is an important thing, between zone redundancy, meaning 2 or more, and zone resiliency, which means equally distributed. And we'll see how that plays out even more when we talk about Kubernetes workloads, because it gets even more tricky. So there's a zone balancing flag on the VM scale set that you need to set. So this is an important gotcha. Because a lot of times people think, oh, I'm enabling zones on my VM scale set, I'm good, right? But no, AZ2 fails, you get calls on your personal phone from the business people like, what the heck, why is our app failing? Well, I thought it was zone redundant, but you're in big trouble. So now let's talk about Azure Kubernetes Service, okay? Because we've got the base layer of our compute foundation for the hosting of our application. Now we want to use a higher order service to allow us to deploy our applications using Kubernetes. So we know with Kubernetes, this is kind of a funny way to think about it, I get it, because virtual machines are inherently not physical, but there's a physical layer of Kubernetes, and then there's a logical layer. And the physical layer, in my mind, is the nodes, right? It's your compute, it's the infrastructure that powers your Kubernetes cluster. And how many people have rolled your own Kubernetes cluster? I thought so. Yeah, there we go, Brad, a couple. So yes, like you can go set up a bare metal Kubernetes cluster. A lot of people do. Like I know for a fact Samsung does. Like most of their data centers, Samsung's data centers are just bare metal Kubernetes. But when you run AKS or managed Kubernetes offering on one of the hyperscalers, the underlying nodes are going to be virtual machines. You layer on top of that physical infrastructure a logical layer that exists only within the mind of Kubernetes. And so these are logical constructs that get provisioned within the Kubernetes control plane that drive how your application gets deployed, how these containers within these pods get deployed onto the underlying infrastructure. And so, yeah, the idea would be if I have my application, this service, and I want to have 3 replicas of it, I'm going to have a pod, 3 pods. I want each of those pods to go to each of my VMs, to be spread across each of my availability zones. But, there's a spoiler alert that it takes a little bit more to, just like with VM scale sets, you kind of have to tell Kubernetes that it really matters to you that they get spread across all of the zones. But before we get into that, I wanted to talk about the cluster autoscaler for AKS. And so this is basically allowing Kubernetes, to scale, just like with those VM scale sets, the virtual machine that support the cluster. So you got your application deployed with pods, and they're running well on these 3 nodes within the cluster. But let's say you add a whole bunch more pods, to do whatever. Maybe it's a busy week and you need to scale up your app. Maybe other teams want to join the party on your cluster, whatever. Basically, there's going to be more pods that are going to be running on these same VMs. It's not going to work. So the cluster autoscaler can expand the nodes, the physical infrastructure of the Kubernetes cluster to support that load. This is called a scale-out scenario that the cluster autoscaler takes care of for us. Another scenario is, okay, I've got my application with 3 pods, and each of those pods are deployed to 3 VMs, VM1, VM2, VM3. What happens when VM3 dies? Now this could be just, VM3 just had a bad day, it's April 20th, like stuff happens. Or it could be the zone just went out. It's also April 20th, somebody had a little too much fun on the backhoe, right? And, zone 3 goes down. It's a joke. These are my personal opinions, by the way, okay? So the cluster autoscaler steps in, spins up a new node in a healthy zone, and our pods are now scheduled across those new nodes. This is called an outage recovery scenario. And so basically the combination of Kubernetes and the cluster autoscaler allows Kubernetes to kind of take over the resiliency of the platform, but you have to communicate to Kubernetes exactly what you want. Because like we saw previously with the VMs, we had to tell Azure, hey, it's really, really important to me that these nodes within this VM scale set get spread evenly across the AZs within this region, West US. With Kubernetes, I might assume that if I have 3 pods and I have 3 nodes in my cluster, that Kubernetes will just put 2 and 2 together and be like, yeah, okay, yeah, we're going to put 1 on each node. But there's no guarantee of that. The scheduler, the system services of Kubernetes could just as well say, well, you know what? I have enough resources on this node, so I'll just slam that pod in there. No problem, right? Because the user, me, person on kubectl or whatever, didn't specify that it was really, really important that pod actually needs to be over there. So what happens? We're in the same situation. Even though the Azure infrastructure is balanced across all 3 availability zones, the pods aren't. So in a sense, like I'm back to square one, right? So it's important that you understand both the infrastructure layer that you're sitting on, and that's resilient, that's step 1. But then step 2, the application layer that you're using, or the platform layer, in this case Kubernetes, that sits on top of that infrastructure needs to be resilient as well. And so the way that you do that, in this case with Kubernetes, Kubernetes has this magical logical layer with all sorts of anatomical things that you can go learn about, deployment, services, pods, config maps, yada, yada, lots of things to learn. There's this also thing called topology spread constraints. That's a mouthful. But basically, long story short, it's an annotation on your service or your application that tells Kubernetes, look, it's really, really important that these pods get distributed across my nodes in a certain way. The attributes it use are the topology key. That's the first setting. And Kubernetes has all sorts of ways that you can do this spread. right? Because Kubernetes is like the Swiss Army knife, right? There's so many different ways of configuring it. One of those attributes is this one, which is essentially the zone. Now, AKS, and I'm sure that the other managed Kubernetes offerings on other platforms, knows how to populate that value on your node. If you're going to roll your own cluster, you probably need to, populate that value yourself somehow, right? But AKS takes care of that for you. So the topology key, basically, if we assume these nodes are spread across the availability zones on our VM scale set, then these nodes are all going to report to Kubernetes, hey, I'm in zone 1, I'm in zone 2, I'm in zone 3, right? And then we're telling Kubernetes these pods need to be spread across this aspect, which is the zone. The next thing that we have is called max skew. Now, skew is a magic word that basically means offset from normal, right? And so if we assume equal distribution is normal, max skew is like, okay, if we have one pod, then 2 pods would be +1 skew from normal, right? That means that each of these nodes will never have more than 2 pods than the other one, right? Which basically means as we scale up, we go from 3 pods to 4 pods to 5 pods to 10 pods to 100 pods, right? Those pods are going to get stacked evenly across the infrastructure. And of course, the cluster autoscaler is, as we run out of resources on those nodes, is going to be stretching out these nodes as well, which then Kubernetes is going to, keep that level. So that's what max skew does. Another one is when unsatisfiable. Gotta love Kubernetes. They've got the most clear and obvious way of naming things, but when unsatisfiable. Basically, in this situation, that means, okay, I've got a bunch of nodes in my cluster. Some of them are in AZ1, 2, and 3, and I'm trying to spread across zones. Let's say AZ3 goes down completely. Somebody had fun on the backhoe, AZ3's down. Now, Kubernetes says, hey, I want to schedule these pods to VM3 because I need to distribute them across all the AZs, but VM3 is dead. It's unhealthy. This topology spread constraint is no longer satisfiable. Like Kubernetes literally cannot schedule the pod to that VM. So what do we tell it to do? Just schedule it anyway, pal. Just do it. There's other options there, which is, don't schedule at all, right? And you might have reasons to do that, but in this case, if an AZ goes down, we don't want our application to be chopped in half, like to reduce the capacity. So we're going to have Kubernetes redistribute those pods to healthy nodes to help keep the traffic flowing. So this is an important configuration at the platform layer, right, in order to make sure that your application is resilient. And so what that changes in this picture is instead of just letting Kubernetes do whatever it feels like, right, and we might get lucky and it might put that pod over there, or it might put it here. We kind of like to be sure. So we apply that topology spread constraint, and we explicitly tell Kubernetes how important it is for us to have our workload distributed across all these nodes, across all of these AZs. And so that, is that's it. I mean, that's how you can achieve zone-based resiliency, fault domain-based resiliency, the pros and cons between fault domain-based resiliency and availability zone-based resiliency, and why it's so important that you need to have a solid infrastructure with that resiliency built in, but then also your job's not done yet, right? Because your application and the platforms that you lay on top of that infrastructure need to also take advantage of that resiliency that you built into your infrastructure. So that's it. I hope you guys like that. This is me. I am the Azure Terraformer. You can find me on LinkedIn and Twitter or YouTube, and I do lots of semi-educational content on there. So thank you guys for coming. Drake and I organized this meetup, and we try and meet Wednesdays. What is it? Second or third Wednesday? fourth Wednesday.
long.
Drake's the brains behind the organization. Okay, so
Then we're in trouble.
yeah. So thanks for coming. I don't know, Drake.
Questions.
Oh yeah, questions. Yeah. Yes. What's up?
Thank you so much today, Mark. Wonderful presentation. Just on a very high level, what happens when, say, an application requires communication between pods? And like we did before, the pods are literally physically scheduled across multiple available zones.
Yeah.
Would the latency become an issue in that case?
So that's one of the reasons why you'd want to have, the availability zone resiliency, because the latency between availability zones is relatively low, right? So you can run low latency workloads like Cassandra, like Kubernetes, like Kafka, and run it across availability zones. So you are taking advantage of that. Does that answer your question? Or was your question more about like how do we facilitate east-west traffic within a Kubernetes cluster?
I think you already answered it. It's the region that's causing more latency issues, not the availability zone themselves.
Yes.
'Cause those are close.
Yes.
Thank you so much.
And the region, typically when you do replication cross region, it's asynchronous. But within an availability zone, we can tolerate synchronous replication, across the AZs. That's one. And Cosmos DB, we were talking about it earlier. That's one of the reasons why Cosmos DB is such a lifesaver, because it makes it super brain dead easy to do cross-region data replication, right? So you can, deploy your databases across regions. What's up?
I'm gonna ask my stupid question. I read all this theory about like resiliency and if data centers go down. Has Azure had data centers gone down? If so, how?
Yeah.
Like, were there earthquakes or like what happened? Like, have you ever had a whole
So-
availability zone go down? Like,
Yeah,
don't know.
we've had availability zones go down.
I haven't been on Azure that long. So like, what happened?
Well, I mean, I will guarantee you this: every time we have an incident like that, we do a very thorough root cause analysis, and we figure out, we ask all the whys. Why did this? Why did this? Why did this? To try and solve that problem, and that's part of what my team does. At Microsoft, like we solve cross-cutting issues in the core platform, and with a focus on resiliency. So.
But it's like, are you saying it's internal errors or is it like wildfires or nuclear war? Like,
I mean,
how does it happen?
We are
Okay.
operating a platform, right? So like, I mean, we're dependent. We have our own dependencies: power, water, intercontinental fiber optic cables. I mean, there's a lot that can go wrong.
You can only get 9s of reliability at a certain point, nothing beyond that.
Yeah.
Just 9s.
Yeah.
So sorry for the politician's answer, but you could probably get more information out of CNN, to be honest. What's up?
Is there a reason why you chose West US?
No, I just randomly picked it. It's not like, honestly, so as a Microsoft employee, we get, slapped anytime we try and take capacity from paying customers. So like one of my favorite regions is West US 3, just because I don't really run into capacity issues there. But every once in a while, if I leave something running long enough, like I get an email that says, we deprovisioned like this AKS cluster that you're running. Have a nice day. And that's what you get when when you work at Microsoft. Like, you guys, our customers, are way more important than me running whatever mad science project that I've got going on. So yeah, no specific reason on West US. Yeah.
It actually doesn't have availability zones.
Oh
I've seen like
yeah.
the
Yeah,
days to be just- to
I
be
randomly
just-
picked it. Yeah, that was unlucky.
So you don't happen to know when it's going to be available.
So the older regions that we're rolling out, that is a funny hack, man. I'm sure all the older regions that don't have AZs yet, we have like timelines for when that's going to be rolled out. But Yeah, that was an unlucky, unlucky random selection of mine.
For the record, every one of our regions had availability zones.
Thanks, Brad.
Do we end the talk on AWS one-upping Azure?
What's that?
Do we end the conference in AWS one-upping Azure? Or do we have one more question?
Yeah, one more. We got a question. Yeah, sure.
More question?
I'll ask a question.
Last one.
Yeah, I was kind of curious about the differences between.
Thank you. I was kind of curious about the differences between the different types of scale set. So you have the scale set, I believe the availability set is what you mentioned,
Yeah.
right? And then the proximity-based set, right? Was that the third?
Proximity placement group.
Proximity placement group.
Yep.
So I was kind of curious if there were any like financial like price differences between those three. I would imagine so, but I was kind of curious if you would be able to go into a little more depth about that.
No, I don't think you just pay for the compute that spins up. The availability sets are free,
Okay.
from what I understand, because it's really just you telling us like, hey, these guys are on the same team, right? And Brad, that's a valid like crit. I think I wasn't there at the time, but like I think at the time like the idea was, oh, it's easier. You don't have to explicitly set the availability zone. These availability sets kind of abstract some of that away from you, but I think thinking has evolved. There's actually multiple layers now within Azure. We still have the fault domain resiliency, but we're adding another layer of at the AZ level. So it's kind of like tiered. So you have region-based, AZ-based, and then fault domain-based internally within the platform. But I think long-term, like the fault domain-based resiliency will be more abstracted from the end users, right? And that'll be something that we just use internally.
All right. Thank you for clarifying.
Sweet. Thank you again.
Thank you.
You're free. Okay. I'll be fast. You're like 30 seconds away from being free.